In software engineering, a reverse proxy server is an intermediary server whose role is to aggregate and forward the requests sent by the clients to the appropriate backend servers or services and to return their responses. This type of server is commonly used for load balancing, which means distributing the requests across the available servers to maximize speed and capacity utilization while ensuring no one is overloaded. Web acceleration, which includes compressing data, caching commonly requested content, or using SSL acceleration to speed up the inbound and outbound traffic flow. Security, which allows multiple services to share and use the same SSL certificate for data encryption. And anonymity, to conceal the characteristics of the origin servers by making them appear as a single unit, by directing all the requests to a single publicly known address, which in turn helps to mitigate security flaws and denial of service attacks. So in this final lesson, we're going to set up a reverse proxy server that will sit in front of our authentication microservice and that will be in charge of forwarding the internet traffic to it. Nginx is a free and open source web server that can also be used as a reverse proxy, load balancer, mail proxy, and HTTP cache. So let's start by installing Nginx using the apt install command and start the Nginx server using the service command. As we're going to use Nginx as a reverse proxy to act as an intermediary between the internet traffic and the authentication service, we're going to configure it so that any incoming request sent on the port 80, which is the default port used for HTTP, is automatically redirected to the port 8000, which is the port the authentication service is listening to in production mode. To do so, we're going to update the default Nginx configuration file located in the site's available directory using the vim command line editor we previously installed and the sudo command, the reason being that this file belongs to the root user and cannot be modified by other users of the system. Once opened, let's replace the content of this file by creating a new server block where the listen directive sets the port Nginx listens to for incoming requests. The server name directive allows to define for which domain name the server block should be applied, where in this case the underscore character acts as a wildcard allowing for all requests. And the proxy path directive allows to define the address to which the incoming request should be redirected to. We can now save and quit this file using the qw command and restart Nginx using the service command once again. Finally, we can verify that the requests sent on the port 80 are successfully redirected by Nginx to the port 8000 of the authentication microservice by simply checking the heartbeat of the service using the following curl command. The transport layer security, often abbreviated TLS, which evolved from the secure sockets layer, or SSL, is a cryptographic protocol that provides end-to-end security of data sent between applications over the internet. By encrypting this data, it ensures that eavesdroppers and attackers are unable to see sensitive information a user or an application transmits, such as passwords, credit card numbers, or personal messages. This protocol is mostly familiar to users through its use in secure web browsing, and in particular the padlock icon that appears in web browsers when a secure session is established. That being said, to enable TLS encryption on the server, we need to acquire an SSL certificate provided by a trusted third-party entity called a certificate authority, such as Cloudflare, DigiCert, or GeoTrust, which is essentially composed of two data files, one that contains the website's identity and public key alongside other related information, and one that contains the private key. The certificate is then stored on the same machine the server runs on and is used by that server to establish a secure connection whenever a client requests or sends data during a process named the TLS handshake. Configuring Nginx to accept HTTPS traffic essentially consists in two simple steps. First, we need to open the port 443, which is the default port used for HTTPS. And second, we need to provide Nginx with the SSL certificate and public key files that will be used for encryption and decryption. So let's start by creating a new directory named SSL within the Nginx directory using the sudo command that will hold the SSL certificate and the public key. Let's now generate a self-signed certificate using the OpenSSL command. Just so you know, a self-signed certificate is an SSL certificate that is not issued by a certificate authority and that doesn't provide trust value whatsoever and therefore cannot be used on a real-life production server. Once we've done that, we're going to open the Nginx configuration file once again and update it with the following values, where the listen directive allows for TLS traffic on port 443. The SSL certificate directive specifies where to load the public SSL certificate from, and the SSL certificate key directive specifies where to load the private key from. Let's now restart the Nginx server one last time and send the following request using the K option flag, which is a shorthand for insecure, as without it, curl would throw an error due to the usage of a self-signed certificate. To wrap it up, I should mention that for an actual certificate acquired from a certificate authority, the certificate and private key files will have to manually be uploaded on the server using the scp command, then manually moved into the target SSL directory using the sudo mv command.